In this example, we're going to graph the function f of x equals 3x. And keep in mind that if you have a function, this notation, that's the same thing as just graphing this function here, y equals 3x. So this is function notation, and this is pretty much the same meaning. The only difference is that this allows you to track what it is you're evaluating in this expression here. So before I graph it, one thing I want to notice is that this 3x, notice that the exponent for the x is a 1. If you're graphing an equation where the highest exponent is a 1, that means when you graph it, it's going to be a line. The picture is going to be a line. And to draw a line, all you need is 2 points, because to any 2 points defines one line that can pass through it. So what I'm going to do is I'm going to create an XY table to track or to organize my information. And the XY table is going to allow me to get my 2 points. Notice they did not give you any x values to evaluate, so you're going to make up your own. And what I recommend is just picking numbers that are easy to evaluate in your expression. So I usually go with 0 if I can, and the next number will be 1, because those are easy to substitute and simplify whenever you're dealing with expressions. So I'm just going to write out both of the formats so you can see that it's the same thing. So f of x equals 3x, that's function notation, and then the other one is y equals 3x. So in function notation, like if I'm going to let x equal 0, you can see there I'll put 0 in place of x, and I'll get this set up. And now on the left side, you're not doing anything with this function notation. It's just saying that we're looking at this expression in terms of x being 0. And when I simplify this, I get 0. So this is letting me know that when I let x equal 0, my answer for y comes out to be 0. So when I let x equal 0, the answer for y came out to be 0. So that's my first point. So in your table, you might see, instead of xy, you might see x and then f of x, because you can see the f of x is equal to your answer, which is over here, the 0. And just so you can see what I mean, I can have x here, and then this could be my output, because f of x is your output, or in other words, your y value. And if I were using this format, you can see all we do is let x equal 0, replace x with 0, and 3 times 0 is 0. So you can see when x is 0, y is equal to 0. So I put y equals 0, and then you can see it's the same exact thing. But one thing I want to point out is that notice that in this format, whatever your answer is, this allows you to see what you use to evaluate to get this answer. Here, you can't see what you evaluated unless you go back into the work to see what you substituted, but you don't know what you evaluated to get this answer. So that's the difference between the function notation and just setting it up in this format here. And I'm just going to repeat. I'm going to evaluate when x is 1 and see what the output is for that. And I'm just going to use the y equal to 3x, this format. So when I let x equal 0, or sorry, when I let x equal 1, 3 times 1 is equal to 3, so that's my output. So for the input 1, the output is 3. Now that we have our 2 points, we can actually graph this out. So I'm just going to draw a sketch, and I'm going to put those 2 points there. So this is my x-axis, my y-axis, and then we have the point 0, 0, which will be here, the origin. And then we got to plot the point 1, 3, so that's going to be right 1, up 3. So I'll put a point there, right 1, up 3, put a point. And now we have enough information to draw a line. And then that's it. That's our graph for the function f of x equal to 3x. And you might see some books recommend to do at least 3 points. And the reason why is if you were to pick another point, let me see if I put -1 in here. If I put x as -1, I would get y equals 3x. Replace x with -1. And then I'll get y equals -3 for that, for the output. -1, -3. If I were to plot that point, you could see that -1, -3 would be somewhere 1, 2, 3, somewhere down here. And you can see that that is going to be on the line as well. And the reason why some books might recommend doing more than 2 points is because you'll be able to identify if you made a mistake. In other words, when you plot your points, you can see these all line up in a straight line. That's called collinear. But if you messed up, you'll notice that one of your points will not be on the line. And then that's how you know you have to go back and fix your mistakes.